All right, this is day 2 of stoichiometry. I'm glad you survived day 1 and you are still here and actively ready to do homework page 2. Again, tonight's homework is page 3 through 4. We're trying to stick to one page front and back. So tonight's homework is to complete page 3 and 4. I'm here to help you guys get a good head start and a jump start on how to do these pages. You probably learned yesterday that you absolutely must have a balanced equation to start stoichiometry at all. So in this equation, you need to make sure that this side of the equation has the same number of atoms as the right side. The reactant side has to equal the product side. So for every 2 aluminums I have here, the first prediction I would make is to put a 2 here. But then when we move to the oxygens, oh yikes, there's 3 on this side and 2 on this side. So you find a common factor. 3 times 2 is 6, and 2 times 3 is 6. Some people just say, I'll just switch the numbers, and then it works out. Okay, no worries. We're going to cancel out this 2 because when I place this 2 here, it changed the aluminum to 4. Keep in mind we distribute in chemistry. Okay. So now it's time to go back over mole ratio. A mole ratio simply uses the coefficients of a balanced equation. So for every 4 moles of aluminum, there's 3 moles of oxygen. This is why balancing is very important. If you don't balance correctly, your mole ratio, as easy as this is to do, your mole ratio will be incorrect because you don't balance right. So you have to make sure, if you don't understand the fundamentals of balancing, that you talk to your teacher and get caught up on balancing, or watch her tutorial videos from last semester on balancing. 4 aluminums, so I'm going to put 4 there, for every 2 aluminum oxides. So this is in a 4-to-2 ratio. Now, depending on what your teacher asks you to do, she may ask you to simplify that and call that a 2-to-1 ratio. All right. Number 5 is actually a review of yesterday. You can tell because you're starting in moles, and the question is asking for moles. So number 5 is just simply a review of yesterday. I will go ahead and put up the T-bar setup just so you can check out how you're doing. If you have moles of aluminum, you have to have moles of aluminum here. And we're looking for moles of aluminum oxide, so we'll put moles of aluminum oxide up here. So again, if we are looking for aluminum oxide, that means that the coefficient of aluminum oxide, which was 2, would go right here, and the coefficient of aluminum, which is 4, would go right there. And of course you would multiply 3 times 2 is 12. Divide that by 4. So you get a nice beautiful answer of 3 moles. Oh my gosh. This is what happens when I don't pull a calculator in. 6 divided by 4. I apologize because 3 times 2 is only 6. And 6 divided by 4 gives you 1.5 moles. The only way the answer would be the same as the product is if they had the same exact coefficients. So, kind of a thing to look for when you're doing your math. So let's get to the first problem. That is what y'all learned in class today. Today, you learned how to convert from grams into moles and from moles into grams. Our first example problem, we are starting in grams So we have 25 grams of oxygen. Keep in mind, don't get lazy with writing out the units in the chemical, because in stoichiometry, in a few days, those are going to be what save you and help you through the problem. So, we're starting in grams. In dimensional analysis, we learned that any time you have grams, you need to go to the periodic table. I kind of have a little logo. All G's use the periodic table. So you have to go to the periodic table for oxygen, and you'll discover that oxygen weighs 15.999, and there's 2 oxygens that weigh 15.999. So 15.999 times 2 gives you 31.998. And that's how much 1 mole of oxygen weighs. So if you notice, we're still in given units. We haven't been able to jump over to aluminum because we haven't hit a mole ratio step. Now that we're in moles, we can compare oxygen to aluminum, but you have to be in moles in order to do that. So now this step is just like what we did yesterday with a mole to mole. For every 4 moles of aluminum, there are 3 moles of oxygen. 25 times 1 times 4 is 100. And 31.998 times 3 is 95.994. So you get 1.042 moles of aluminum. So we did not switch until talking about aluminum till here. And whatever your final unit in chemical is in your T-bar is the one in your answer. I'm going to go ahead and do the next one as well, because this is a mole to gram. So instead of starting with grams, like in number 6, we're actually starting in moles. And we're looking for grams. So you write your given, 50.5 moles of aluminum oxide. And so immediately, just like every other problem we've done on this tutorial, you have to write your given unit and your given chemical down at the bottom. The last problem we had to convert to moles to get to this ratio step, but if you're already in moles, that's when you do your ratio step. So for every 2 moles of aluminum oxide, we will be able to know how many moles of oxygen are produced. It's a 3-to-2 ratio. So 3 moles of oxygen for every 2 moles of aluminum oxide. But we want to know grams, so you're probably thinking, oh man, there must be another step. Absolutely. At this point, we are no longer talking about the given. We are talking about what we're looking for. We have to copy this down here, mole of oxygen. And the reason I ask you to circle your coefficient step is because anywhere outside of this step, mole will always be 1. The only time you use coefficients for mole is when you're comparing apples to oranges, when you are doing your mole ratio. Other than that, outside of this step, mole will always be 1. And then we're trying to convert moles of oxygen to grams of oxygen. And just in the sake of being a little lazy, last problem, do you see how we calculated the molar mass of oxygen already? we're going to steal that number, 31.998, because that is the mass of 2 oxygens. We will then multiply the top and divide by the bottom. So 50.5 times 3 times 31.998. The only number on the bottom is 2, so I'm going to hit divided by 2. And you get 2,423 grams of oxygen. Okay. The next couple problems, we will give you the balanced equation. And just keep in mind, making sure you understand the given is where you start, and the question is where you're going. Whatever's written after how many will be the last thing on your T-bar. If the units don't match, it's a 2-step problem. If you've got grams and moles, it's going to be a 2-step problem. I'm going to go ahead and do one more with you for the tutorial today. For every 6 moles of zinc, so immediately I would have to go moles of zinc and copy it down to the bottom. You're probably thinking, is this a coefficient step? Absolutely. Once you start in moles, you can go right to your coefficient step. You got 3 moles of zinc for every 2 moles of aluminum. But we didn't want to know moles of aluminum. We want to know grams of aluminum. So just like on the last problem, for every 1 mole of aluminum, you're going to produce whatever the molar mass is of aluminum. So again, after the mole ratio step, you are completely done with the given. You'll notice everything says aluminum from that point. So you pull in your handy dandy calculator. 6 times 2 is 12 times 12 times 26.982 divided by 3 is the only number on the bottom. When I say 3 is the only number on the bottom, that means ones don't alter your math. You can multiply or divide by 1 all day long, and it won't change the math. So 107.928, which in sig figs, there's 3 in the problem, so I would just call this 108 grams of aluminum. The next problem is a mole to gram, just like this. So I'd like to work number 10. Okay. Number 10 is starting in grams and ending in moles. And again, the easiest way to tell is by using 2 different color highlighters. Highlight the given. If you don't have highlighters, box one and underline the other, however you want to do it. I'm a very colorful person, so I prefer using highlighters if I have them ready. 100 grams of aluminum sulfate. If you're having a hard time with formula writing, this is kind of a nice unit to be able to say, well, that doesn't have sulfate, that's zinc, so you can actually practice your formula writing and your identification of compounds. I think that's a great part of this unit. You could, of course, if you felt like it, write the words aluminum sulfate here. Now the problem is we can't do this mole ratio step because we're in grams. Before we can do a mole ratio step, we have to convert to moles. So I've got to write grams of Al2SO43 here. So this is just converting your gram to a mole. Okay. I'm going to actually use this space right here because I write really big if y'all haven't noticed. And I didn't really leave myself enough room to do the molar mass of aluminum sulfate. Aluminum sulfate, there are 2 aluminums, there's 3 sulfurs, and there's 12 oxygens. We distribute the 3 to the things inside of the parentheses only. 26.982 is aluminum's weight. 32. Guys, we're getting these masses off the periodic table. 32.066 is sulfur. And 15.999 is oxygen. I'm going to go ahead and get the total mass by multiplying these 3 numbers and adding them together. Again, a shortcut for the calculator, you can actually just do all of that in one swift move. 2 times 26.982 plus 3 times 32.066 plus 12 times 15.999. So the total is 342.15. So that's the number that goes here, 342.15. And again, all of this is the given because we had to convert grams to moles. Now we are going into the coefficient step or the mole ratio step. So now is finally the chance we get to say moles of zinc sulfate. And again, if you're having a hard time with your formula writing, zinc and sulfate, there you go. So zinc sulfate has a coefficient of 3, and aluminum sulfate, there's nothing there. So just like if there's nothing there in a formula, that means that that is a 1. So you're going to multiply the top. That's easy. 300. 100 times 1 times 3. We're going to say 300 divided by 342.15. And that would be my answer. Looks like I need 4 sig figs. 1, 2, 3, 4. So my final answer, oh, I ran out of room. Look at that. I'm going to go rogue and go over here and put my answer because I ran out of room. And my unit is moles of zinc sulfate. Thank you for joining us today for the tutorial of mass to mole and mole to mass. Feel free to bring any questions to class that you have, and have a great time trying to finish the rest of this up on your own.